On question 3, let's check to see if this is a perfect fifth root, and we're going to access this in the calculator. Most of you have an exponent button to the left of the number 7, and it looks like this, and above it you see the symbol. It's a radical, and you have an x where the root number is. This is what you need. You do not want to type the x squared button because the inverse of that is a square root, and this is a fifth root. So we don't want that. So what we need to do first is we enter 5 for the root value, and then we're going to type the second button, which is that yellow or blue key that you have in the top left corner of your calculator, and then you will type the exponent button. So you type this button here so that you can get this radical on your calculator. And so what you should see on your calculator screen now is you have 5x root. So it's a good idea to use parentheses here, especially if the number is negative. So let's open with parentheses, and let's now type our value 3125, close parentheses, and then at that point you can press your equals or enter button. So press equals and you get 5. So since we did not get a decimal, that means that this is a perfect fifth root. It means that 5 to the fifth power is 3,125. Now another way around this, if you're not comfortable using your radical button on the calculator, is you can experiment with values to the fifth power and create a list of numbers until you approach this. So this is what I would do. I would use my exponent key, and I would do 2 to the fifth, and I would get 32, 3 to the fifth power, and just keep working your way up, and that's 243. And as you keep getting higher, you'll see that you're approaching 3,125, and then when you press 5 to the fifth, you will get exactly what you're looking for. So that's another way around it. Now on number 4, since this is a fraction, you can split up the fourth roots. And so if you don't recognize what these values are, use your calculator, or you can create a list of numbers to the fourth power. 2 to the fourth is 16, 3 to the fourth is 81, 4 to the fourth, 64, and on. So the numerator becomes a 2. Now the fourth root of 625, if you use your calculator to get that, or if you create a list, you should get 5 for that value. So the fraction is 2/5 when you simplify that. On question 5, we have the cubed root of 64, a cubed, b to the 9th. So we need to figure out what's the cubed root of 64, and then we need to deal with the variables as well. So the cubed root of 64, if you remember from working with these values, and create a list, and 4 cubed, I need to go back on this previous one, 4 to the fourth, I'm sorry, it's not 264, it's 256, so it's not 64. The cubed root of 64 is 4, so I was thinking 4 to the third is 64. So this right here is a perfect root. So that is 4. Now with the numbers, with the variables, you're supposed to divide the powers by the root. So how many a's come out? Well, 3 goes into 3 one time, none left over. 3 goes into 9 3 times, so b cubed, none left over. So this is the answer for 5. On number 6, we learned a property that says if your root matches your exponent, and especially if it's a whole group raised to that, these are inverse operations of each other, and so the expression comes out. So the root cancels that out, and this answer is just y minus 2.